All right, you guys, we've got lesson number 13. We're talking equivalent expressions today, and most of these problems, I'm going to show you a trick, as you can see, and we've talked about this trick a little bit in class. But there are some very difficult, like algebra questions that can be tricked, as you can read up here, by plugging in some easy numbers and just process of eliminating through the answer choices. So if it's pretty quick and simple, I will show you algebraically how to do the problems, as you can see here. And that easily, very, simply gets us the answer of B for number one. But I'm also going to talk about a trick where if you feel like your algebra skills are not very strong, or you feel like you might make a mistake algebraically, I'm going to show you a trick that will help you kind of get around that. So like I said, the algebra way to do this is to distribute the minus sign. And I am starting out with some basic problems and getting more difficult as I work my way through. But when you distribute the negative sign, this changes to negative, this changes to negative, and then we just combine like terms and we get 13W. That's not too bad. But if you really feel like algebra is not your jam, then why don't you just pick a random number for W, and you can do this trick anytime you see equivalent expressions. Like that's the title of this lesson, right? So let's look at finding this trick. Just pick an easy number for W. I'm going to pick 1. Okay, and I'm going to plug 1 in for all of these W's right here, and I'm doing my work right here. So I get 20 times 1 minus, and let's make sure we keep the parentheses around 4 times 1 plus 3 times 1, and then we're going to subtract those, so we end up with 20 minus, this ends up being 7, which is 13. And so 13 is like my magic number here, and I am going to go through all of these answer choices and plug in the same number for W, the 1 that I chose. And when I plug in 1 right here, I get 10. That is not equal to 13, so that's not the right answer. When I plug in 1 here, I get 13. That is the same answer that I got over here. When I plug in 1 right here, I get 19. That is not this number, so that's not the right answer. And that's the way to eliminate your answer choices by using this trick, which is pretty cool. Number 2 is a pretty complex algebra problem because we have a lot of different variables and a lot of different exponents and a negative exponent, which I know we all hate. But all I'm going to do algebraically, if I'm okay with algebra, then I'm taking m to the 4th times another m, which means there are 5 m's total. And look, right away, I know my answer. Okay, but the same thing we're going to do with the q's. When we combine, you have 4 q's over here, and you're multiplying by 5 more, which makes 9. There it is. And that's what I wrote here. And then z to the negative first and z to the 3rd. So one of these negative z's is going to cancel one of these 3 positive z's. So when you combine them, -1 plus 3 is 2, and that's why we get this. If exponents are not your thing, let me show you this trick. Let m, q, and z be any number. So I might pick a different number for m and for q and for z. And what you could do, I'm not going to do that on this one because it might take a little bit longer since there's 3 variables, but you can pick a positive number for m, for q, and for z, and plug it into this and use your calculator and get an answer and see which of these 4 answer choices that equals. That would be a little bit harder for this one, but that is another way to get around that question. For number 3, I think I just went right to the trick for this one. But what I am noticing is we have a GCF here. You can factor out x minus 7 from the numerator, and you can factor out a 2 from the denominator, and then your x minus 7s will cancel, and whatever you're left over with will likely be one of these choices. So that's how to do this algebraically. But this is kind of an intimidating question for most of my students. So what if I picked a number that falls within this requirement? It says x has to be bigger than 7. Okay, great. I'm going to choose 8. Okay, you have to follow any directions that they give you. Up here, it told me that all the variables had to be positive, so I'd pick positive numbers. Here it says it has to be bigger than 7, so I'm picking 8. And then I'm going to plug in 8 everywhere I see an x. Here, 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 and here. And I did that here. I plugged in an 8 everywhere I saw an x. And when I crunch that number, it might not be a nice, easy, whole, beautiful number, but I got 30.5. Okay. And so now what I'm going to do is I'm going to take the same number, the 8, and I'm going to plug it in right here. And when I plug in 8 for that x, I get 8 minus 7 divided by 5, which is 1/5. That is not equal to 30.5. This is not the right answer. When I take the same number 8 and plug it in for this x, I get 64 minus 3, which is 61 divided by 2, which is 30.5. Ding, ding, ding. That's my answer. Kind of cool, right? And you can see that I plugged in 8 for this, and I got answers that were not equal to 30.5. So I know those are not the right answer either. Number 4, Which of the following is equivalent again? So yeah, we could FOIL this out, distribute the negative sign, distribute the 2, combine all of our like terms. That would take even me, a math teacher, a few minutes. And that would kind of suck, to be honest. Let me see if I can use the trick. I'm going to pick x equals 1. I usually pick 1 because it's a really easy number to plug in. And I'm going to plug in 1 everywhere to the original problem that I see in x. I did that here. You can check my work. Make sure we're being really close. We're being really careful with parentheses here in order of operation. So 2 times 1 is 2 plus 5 is 7. Then do the square. 1 minus 2 is -1. And when I take 2 times 4, I get 8. And yeah, that's a double negative. Just be really careful with the details, okay? If you got a graphing calculator, which you should have, you can type it in exactly the way you see this with parentheses and everything, and you should get it correct, and you get 58. So now my goal is that I'm going to plug in this same number for x over here and see which one equals 58. So when I plug in 1 here and 1 here, 1 squared is 1 times 4 is 4. Got it. 21 times 1 is 21. Got it. Plus 33. Got it. That equals 58. Wow. I don't even have to check any of my other answers. I could, and in fact, you know, to be smart, if I had some extra time, I should probably check all of these other ones, because occasionally if you choose x equals 1 and plug it in, which I'll do an example like this later, you might have 2 different answer choices that both equal 58. So in that case, I should choose a second number like 2 and plug it in, and that will eliminate my answer. I'll get to that when I do one of those problems later, but just be careful. I would highly recommend making sure that you can eliminate all 3 of these, and for this problem it does. You can check that in your head probably pretty quickly, because x equals 1 is pretty simple to plug into all of these, and you don't get 58 for any of those other answers besides letter A. Number 5, I was talking really fast there, sorry. We've got x squared minus 5, and look at all these answers. They look kind of weird. What I would do algebraically is I think these answers come from, I'm not sure what I would do algebraically. I'm going to do the trick, x equals 1. So I'm going to plug in 1 right here, and 1 squared is 1 minus 5 is -4. Great. I'm going to take the same 1, and I'm going to plug it into all of these and see which one equals -4. So when I plug in 1 right here, I get 1 plus root 5, and then I square the whole thing. That gives me a decimal. You can check it in your calculator. This is what I'm typing in, and I'm squaring it, and you do not get an answer that's -4. And the same thing happens with letter B, so I'm eliminating these right away. When you plug in 1 to either of those answer choices, I don't get a nice whole clean -4. I get a random decimal, so that's not the answer. When you plug in 1 right here, and when you plug in 1 right here, it looks like this, and you end up foiling it. And when you foil, because we have opposite signs here, the middle terms with the radicals cancel out, which is great. Or you can just type this in your calculator, and you get -4. There's our answer. And you get 0 here, which is not equal to -4, so D is not the right answer. Number 6 is a pretty crazy looking expression. I would try and factor something out of this to be left over with that if I were doing it algebraically, but it might take a little bit of like playing around and like figuring out factors in my calculator and stuff. So in this case, let me see if I can try and outsmart this. What if I plug in y for 1 for y? So I'm plugging in 1 right here and 1 right here, and then I crunch that number and I get 36. Okay, great. So what if I plug in 1 over here? So I'm just plugging it in. Remember, it's for y. I know we have an r over here, and that's okay. So I'm just leaving r in the equation, but y becomes 1, and y here becomes 1. And I can simplify this. 1 to the 4th is still just 1. 15 minus 6 is, or 15 minus 9 is 6. I still have this r hanging out, but I end up with an answer for r. Weird. Cool. So I guess I would type 6 and move on to the next question. Okay, kind of a weird question, but this is a pretty fun trick. Let's look at number 7. Oh, this is the one I was talking about where sometimes you can eliminate one answer but not the others. Okay, what if for this equation, notice notice how for all these problems you see equivalent expressions in the wording here. That's your clue that you could do this trick. What if I pick x and y both equal 1? I don't have any restrictions. It just says x can't be 0. Okay, great. So then I'm going to pick 1 for each of them, and I'm going to plug it into the original question. When you plug in 1 for x and 1 for y and 1 for this x, then you get this, which is just 4. Okay, so what happens when I use both of these numbers and I plug in 1 here and 1 here? I get 8. So that's not the right answer because I'm trying to match it up with 4. But if I plug in 1 here and 1 here, I get 4. So I might think that's the answer, but this is what I said I highly recommend unless you're completely out of time. You got to check the other ones just to make sure, because when you plug in 1 here and 1 here, you still get 4. And when you plug in 1 here and 1 here, you still get 4. So sometimes choosing easy numbers like 1 isn't the best. At least I've eliminated one answer choice. But for the other 3, I now need to pick a different number. What if I choose 2 for both of them? Okay, so I'm going to kind of do the same trick. And yeah, this is kind of a hard question. Okay, so it might take a few minutes. I might have to flag it and come back to it. But what if I pick 2 for both of them? You can see my work here. I'm plugging in 2 for this x, I'm plugging in 2 for this y, and I'm plugging in 2 for this x. And when you crunch this number in the calculator, I get 32. Now I'm going through my 3 remaining answer choices, and I'm plugging in 2 and 2 and trying to figure out what answer equals 32. And it happens to be the last one. When I plug in 2 here and when I plug in 2 here, you can check it with your calculator. Just type this in and you get 32. And the other 2 answers are not equal to 32. So I know this is wrong and this is wrong. All right, number 8, equivalent expression. Looking at the answer choices here and seeing that I have something squared plus or minus a constant, that to me tells me that I should do completing the square. And if you know how to complete the square, then you go nuts, because I freaking love completing the square, but most students hate it. So let me try the trick. Again, I'm picking 1. If I plug in 1 for x here and 1 for x here, then I get the number 11. And I'm going to go through my answer choices, and I'm going to plug in 1 for all of them, as you can see that I did, and I'm going to try and figure out which one equals 1, which is the second answer. Number 9. In order to solve this algebraically, I have an example for you. I noticed right away as a math teacher that this thing has a GCF, so that I factored out a 6 and I canceled. And that was pretty simple. And so then I was just left with a 4 on top and x plus 7 on the bottom. And this is just asking me what is b. So I kind of stumbled upon the answer just factoring out a GCF. But if that's not your jam, pick a number. Here's a restriction that's bigger than 0. I'm going to pick 1 because I freaking love plugging in 1. Okay. When I plug in 1 to the original equation, I put a 1 right there for x, and I get 1/2. And so from now, what I need to do is I need to equal this to 1/2. I actually have an equation to solve because there's nowhere to plug anything in over here, right? So that's kind of a problem with this trick, but that's okay. We can still use the trick. I simplified this by plugging in 1, and I simplified it to 1/2. And it's telling me that it is equivalent to this. So I wrote my equal sign, and I put my 1/2, and I am setting it equivalent to this. And all I have to do here probably is, I'm plugging in 1 for x still. Yeah. So now that I have this x, I am plugging in the 1, which is right there. So I get 4 over 1 plus b equals 1/2. I think I'm going to cross multiply. 4 times 2 is 8. 1 times 1 plus b is 1 plus b. Therefore, I got 7 equals b. Finally, that was a little bit harder. I had to do a little bit more of a workaround, a little bit more of a trick, but I got it. I still picked a number for x. I simplified this, I got an answer. Since I had nowhere to plug any x's into like I did for all the other problems, I had to think to myself, okay, it says it's equal to this. So I'm going to take the 1/2 and I'm going to equal it to this. And for then, now I have an x that I can plug in. So I'm still taking the same 1 and I'm plugging it in right there. And then I just cross multiplied. 8 equals 1 plus b, and I got 7. I think I have 2 more, you guys, and then we are done. Algebraically, how do you do this question? This is pretty simple. We just distribute the x, and it says 2x squared. That's great. What is the value of a? Well, it happens to be 7. Okay, that was pretty simple. But how does the trick work for this? What if I plug in x equals 1? And if I plug it in right here and right here, I get 2 plus a. And so if I plug in 1, over here I get 1 and 1 right there for those x's, and I'm showing my work here. And they're supposed to be equivalent. That's what all these problems are about, is equivalent. So if you plug in 1 to this, you get an answer. Plug in 1 to this, you get an answer, and you equal them to each other. And you just solve and you get 7. Okay, last one. Let's see. We have a sum. So I have this quadratic and I have this quadratic, and it asks you for the sum, which means plus. Okay, so I'm adding them together. I'm just being really careful and really diligent, combining my like terms. Negative 2 squared and positive 3x squared. I spoke wrong. Negative 2x squared and positive 3x squared is positive 1x squared. And I've got double underline for my x terms. When you add 1 and 7, you get 8. And then my constant terms, positive 31, negative 8. Be careful with that. It's negative 23. Therefore, the a is 1. You remember quadratics. The b is 8. Excuse me. And the c is 23. And this question just asks, what's the value of a plus b plus c, which is 32. And I made a note to myself that I can't really trick this one. Okay. Anyways, hopefully you learned something. This is to be used if you get stuck, or if algebra is not your jam. You can still get a lot of questions correct by kind of outworking the system. So thanks for watching and thanks for playing. I'll see you in class.